Hello guys and welcome back. So now we're going to create the emission for the smoke drill. And with the particles, when we did the particle sim, we went inside and changed the jitter birth. But if we had this off, we're gonna get the gaps in between the object, and we have to increase the number of sub-steps to fix that, and it's going to be really slow. Same issue is going to happen with the smoke solver. It's actually the overhead is much bigger to fix this in the smoke sim itself. And I'm gonna propose and share with you guys the workflow that I use to basically create a source that doesn't require any sub-stepping. And the way we're going to do that is by scattering points like we did here onto the mesh, and then after they get deformed, we're going to isolate the parts. We're going to isolate the parts that we need. Come on. Okay, sorry about that. We're going to isolate the pieces that we need and then create a source from them. And I'm actually going to start implementing it, and I think it's much better to do that versus having to try and explain a complex process. So let's do this. Let's copy all of this and let's create a new network. Smoke source. I think need more. This. Let's actually copy these guys as well. Okay. And what I want to do is I want to isolate the points that are moving really fast as a potential source, and then we're going to trail those points a few frames before. So we're gonna take this. Actually, I can do this. Let's put down a trail node, and let's set the trail to 6. I'm gonna leave the settings to be the default. As you can see, we're copying the geometry backward in time six times. And if we can isolate these points and connect them, if we can identify this point where it is in the previous frame and so on and so forth, we can create an actual primitive, an actual spline. And then from that spline we can resample it and increase the number of points and convert that into a smoke source. So let me show the process here. First of all, we need a way to track the points. We need a way to track these guys. So I'm going to create a wrangle node, and after the scatter, I'm going to say at IDs equal at ptnum. Just simple as that. And now we have the ptnum attribute. We have the ID attribute. We're going to trail it, but I don't want to trail everything because the process is quite heavy. So I'm going to use the velocity and delete anything that is not moving, and only trail these guys. Okay, and then I'm going to use an add node. Actually, let's lower the number of points. I still feel it's heavy. Let's do 10,000. Okay, and then in the add node now, I'm going to set it to polygon by group by attributes and then ID attribute. And look at that, we created a spline that connects the pieces together. We can increase this a bit to create a longer trail, and with this now we can resample it. Okay, we can take the existing points and resample them, and this will create more points in between the positions. And then actually I think we need more points, but this part scares me a bit because there's a lot of points. 1 million. So let's set it to 2. Yeah, something like that. And what we can do after the resample, we can convert this into an actual volume. Okay, so let's create a VDB from particles. I'm gonna set this to 1. I want it to be big to start with, and then lower it as I need. I don't need a surface field, I don't need an SDF, I need a density. I'm gonna lower this to 0.04 because the point size is needs to be small, and then the minimum radius is going to be 0.1. So let's connect this, and let's lower this to 0.1. It's quite small. Let's change this to 0.05. Cool. And I'm actually going to transform both these guys before. I'm going to transform them down 10 times like we did with all the other setups. Otherwise the file is too large. The size of the scene is too large. So, okay, looks good. Cool. So let's see what's happening here. The transform is not working anymore. So let me do it after the unpack. Still not working. So let's do a time shift and provide a reference frame. Yeah, that fixes it. Cool. And I'm also going to add a delete node. I want to delete everything, all these points. I don't want to include them because they're making the domain bigger for no reason. Sorry. I'm gonna copy an existing delete node that has the correct domain. Actually going to reduce it down. Cool. Let's trail that. These guys, and let's do a VDB from polygon, and let's increase the density. So I'm gonna put down a volume wrangle node just so we can visualize it better, and let's say f at density multiply equal by 10. Cool. It's our smoke source. And let's increase the resolution a bit more, 0.25. And let's increase the radius here. I want to capture, yeah, something like that. It's quite thick at the moment, but I think it's going to be fine. And as you can see, the fast-moving objects are also getting this full trail. But now the main issue is that we have this very uniform emission, and I don't like that. So what I'm going to do is I'm going to create a linear ramp that starts white at the tip and black at the bottom, and use that to multiply the volume itself. So I'm going to create a UV texture node, and with this I'm going to set it to rows and columns. I'm going to set the attribute to point, and this is going to create a UV coordinate that does what I just described. So let's put down a color node and view this result. I will explain what is this in a second. So RAM from attribute test, and you can see now we have black and white ramp, and that's what we need. The UV coordinate is actually a vector, a UV, it's a 3 float, and to visualize it here, this only works with, as far as I know, with floats. So I simply copied the uv.x into this test attribute. Cool. So let's go into the VDB from particle and add a new field. And I'm going to actually need that. Let's call this ramp. I'm going to sample the VDB field called ramp, and let's call it ramp. And now we have two fields, the density and the ramp field. And what I'm going to do is I'm going to simply multiply the density by the ramp. As you can see now it's inverted, so we want to invert the result, and we can do that by adding 1 minus the result, and now it's inverted. I'm gonna lower the this guy a bit, and you can see now we have a soft a source with a nice trail behind it. Okay, the next part I want to do is I want to, let's say we have different objects. Okay, some pieces are big and some pieces are small. I want to emit smoke that is denser when the object is bigger, and smoke that is thinner and more transparent when the object is small. So what I'm going to do is I'm going to measure the area when of the object of each primitive, and I'm going to store that as an attribute called area. Right now it's a primitive attribute. Here I'm going to promote that into a, actually let's move this here and do the promotion all at once. We can do it here. So area, from primitive into a point attribute, and now it's been inherited as well. So let's take a look at this area attribute at the point level, and let's take a look at it here. So the area goes from 1.6 to 0.03. Let's create a color, and let's say random from attribute, and let's see if this gives us something. Yeah, it doesn't give us much. So let's do a point VOP. Okay, and let's import the area attribute. I want to visualize it. I'm going to put down a fit range. Let's say it starts at 0, and then the max is 1.7. And let's connect this into the color. And you can see now certain parts have brighter color and the others are darker. So we're going to use this area simply as a multiplier. I'd like it to be I like this range that goes between 0 and 1.6, and we're going to simply use that, sample that in here, call it area. I'm going to sample it here. I'm also going to use it as a multiplier for these guys. So we want to multiply the density by the ramp and by the area. And here should be fine. Let's make sure it's getting all the way in. Add density, multiply by area. Yeah, I think it's working. Let's do a version without the area. I'm not seeing a huge difference, if any. I'm not sure why is this. Let's try. Yeah, I don't think it's working. at the moment, even though there is data in there. Maybe I missed something somewhere. Let's copy this point. So the area is working. I see a difference here, white and then black. I'm not sure why it's not reflecting in this. Yeah, I'll double check this later and see what's going on. But the idea is, I think you guys got the idea of what I'm trying to do. And so far we've created the trail, the smoke source, and it has a nice fade off, and also has the ramp, the area, which vary the intensity based on the object. So let me import the one that I pre-made already. And let's increase the density for just to visualize it. I'm actually going to use the visualization node. I don't want to change it. Set this to 10. I'm going to turn on the max viz, and this is our smoke source. Cool. So in the next video we're going to create a smoke sim that basically uses this as the source. I'm going to use that as the smoke trails for our RBD simulation. Thank you guys for watching, and see you in a bit. Bye bye.